All right, we are live, live and learning. Hi, everybody. Welcome to another show. Today I'm joined by the one, the only, the amazing, the inimitable Dave Cramer. I hope I didn't botch your first or surname there, sir.
Oh, we're all good, but I don't think I'm. You humble me though.
What?
You humble me though.
Oh no. Anybody who supports as interesting an effort as you do deserves all the honorifics I can throw at him. I'm really glad you're here. I'm a huge Postgres fan, and you, I'm told, do some of the work. And when I say I'm told, I mean by the internet and decades of articles, code, and discussions. That's what tells me. Can you introduce yourself before I butcher it?
Sure. My name is Dave Cramer. I have been working on Postgres for longer than I'd care to admit to, somewhere around 1999, even before Postgres was cool. I'm a Canadian, currently living in Florida. Some people may ask why, but that's where I'm at. Weather's fine. As far as Postgres work goes, I've been the maintainer of the Postgres JDBC driver since 1999. I've also picked up some other work with PLR, it's a procedural language for R. I recently picked up the ODBC driver as well, so I'm maintaining that, moved that to GitHub, seeing a lot of good uptake on that. And that's sort of where I'm at this. Oh, I'm currently working for Amazon too. So, in the open source community, Amazon is now, got a fairly substantial Postgres open source team that's dedicated solely to work on the Postgres project.
Really, that's wonderful. That's wonderful. I mean, Postgres I've never felt like it was particularly vendor driven. I can't point to the company behind it. Because I don't feel like there is one. Maybe I'm wrong. Maybe I'm just an idiot. Is there any single company that we could have said at any point in the last 30 years was the company to go to affect change in that project, or has it always been a sort of loose coalition of contributors?
That's an interesting question, the way you worded it. that affected change. I think there was a couple things. There was a long time ago, actually, a guy named Ned Lilly tried to create a company, and he was a little ahead of his time. It was called Great Bridge at the time, and it had a number of the core members in it. I think it was probably in the early 2000s when he tried to do that, and it didn't succeed. But then we had another company, Enterprise DB. They were they did a lot of marketing, so there was a perception that they were the Postgres company. That's sort of never been true. They did a lot of work on that, and a friend of mine just told me that Great Bridge was 2001.
Wow. Enterprise DB, actually, it's funny you mentioned that. Oh, hello. Hi, everybody. We started, if you're wondering, it's live right now. Hello. As you come into the chat group, just let us know where you're coming from, because I guess you're in the East Coast and I'm in the West Coast of the United States at the moment. So I'm wondering where all these wonderful people who are joining us are from. By definition, it'll be, 9 o'clock in Paris and 8 o'clock in the UK, and extrapolate from that a few hours more, and you're already looking at midnight, in or near India, and then very early in the morning, way too early to wake up yet, in East Asia, and so on. Hello from Algeria. Hello. So thanks for joining us. Okay. So anyway, yeah. So you mentioned Enterprise DB. That's actually I do remember them. Are they still around? I don't know.
They're very much still around. They actually are pretty significant. So when you asked the question, it was like affected change. And that's an interesting question, because the people that affect change are the core contributors and the people that are writing code. So we've always been sort of distributed across a number of companies. In fact, the organization is the organization is interesting because there is a core group of people that are kind of they have the power to make you committer or not make you a committer and do things like that. And
Right.
they, by design, they make sure that there's no way that there's no majority in any one company. And then,
Right.
right. And in fact, at one point, somebody moved from one place to another and there was a majority. So they actually had to add core people to balance it out. And then after that, there's all the committers are like literally all over companies. But now we're seeing a little bit of consolidation into sort of the hyperscalers, Amazon and Microsoft, particularly, as well as ADB. So there's the three largest. If I group them all together, that's the three largest committers.
Yeah. But Enterprise DB, I give them credit at least for being first, because I remember them back in 2004, 2005. They were talking about. They had I remember the reason I first learned about them was that there was a ERP thing called Concurrency.
Yep.
That was Oracle only, and Enterprise DB had done a port of it that made it work on their Oracle compatible Postgres. How much of that work has since been consolidated and actually just merged upstream? Like, do you still need is it still a separate effort to do Oracle compatible, or are those just part of core Postgres at this point? I wonder.
I don't think there's I don't think a lot of that got merged in. Enterprise DB still sort of sells that as a product, that their Oracle compatibility layer. There is some Oracle compatibility, but it's not too much. I mean, the project itself is not. We don't really bend towards, it works in Oracle, so let's make it work here kind of thing.
No.
So that doesn't happen too much. But yeah, Enterprise DB certainly had mind share for a long time.
Yeah,
they were first, and they did, market Postgres quite a bit. And then obviously more recently we've got the bigger companies the hyperscalers coming along and obviously marketing it well.
My first introduction to Postgres was in the 90s. And the reason it was in the 90s was because that was, as opposed to like the early 90s when I first started using computers, was because that was my first introduction to Linux. And, I don't think people appreciate that up until, version 8, there was no Windows port.
Oh, yeah. That was about 8.4, I think, or 8.5. So.
Yeah. Which meant that if you're one of those people who is trying to get an app out the door and you're on the very large majority of the operating systems out there that are using, or the deployments out there that are using Windows, up until that release, which now is in the distant past, but at the time it was, decades into Postgres' life already. There was no Windows port, so like you had to run, and this is before virtual machines were ubiquitous, and certainly not Docker was not there, and I sort of think cynically that MySQL had the day in the very beginning because it was like a cockroach. It was just everywhere, and you could run it on Windows. It wasn't particularly well suited to run on Windows, but it did run there, and it was easy to get started. And whereas with Postgres, I think I've always loved Postgres. It is the better database in my not so humble opinion, but it was just so painful to get started. Now, of course, Docker, who cares? It's I can run 1,000 Postgres before most people can whistle. It's just an amazing result. But I think that cost Postgres a little bit of time. I always wondered about this. I think about this a lot. Like, why did this provably inferior thing ever get more popular than Postgres? Why? And
I have some opinions on that. I think the other bit. So there was two. In my mind, there's two big issues there. One is there was a perception of speed difference between MySQL and Postgres. So one of the downfalls, if you will, of Postgres is that we shipped with a very, very extremely conservative configuration. So when you started it up, you got very little memory, and so if you ran any queries of any size, they were very, very slow. You had to tune it to make it work, and that didn't help us, but it did run on everything, and so that was the reason why it was shipped that way. Secondly, I think the LAMP stack was just ubiquitous at the time, right? So it was like you downloaded the LAMP stack and you got
MySQL.
You got SQL, but you got Apache and you got PHP or whatever,
right?
And you could write some code, and I do think that and the one thing about MySQL was it was pretty forgiving if you made mistakes. Like if you put in to the point where it would actually accept bad data. So, it didn't error out. So, for people that were not sort of computer science experts, it kind of did everything for them. They could get their application up and running, and they didn't have to fight with it. And then, they were able to, turn a dime and away you go. But with Postgres, you had to be a little bit more careful. You had to get everything right. It was a little more exacting, and that didn't really. That's not it's not as pedestrian, let's say, as MySQL. So I think you're right. There was a huge mind share that MySQL had for a while that Postgres did. Now I think what we're seeing now, though, is the enterprises are going, we can't accept bad data. We want transactions to actually work, and we can actually get the performance out of Postgres that we need. So that's where we're starting to, the curve is definitely going the other way.
Oh, for sure. And I actually so one of the things I'm always reminded of is back in the early 2000s, we heard all the time that Google was using MySQL for AdWords, right? And I remember just thinking, well, of course they're using MySQL for AdWords. It's a NoSQL database. This is the original highly fast NoSQL database. In that, at the time, the default configuration of MySQL was MyIASM, which was the table engine. That thing didn't understand referential integrity. It didn't actually care. It would silently accept if you said this key references that table, that ID. It would silently accept that DDL for the foreign key, and then not do anything when you inserted data that didn't reference a valid ID, right? It didn't actually honor the constraint. What's the point of a relational database that doesn't understand relationships, right? Like it was broken by default. So of course it's fast. If you don't have to honor referential integrity, then yeah, fine, you can be real fast. DevNull's super fast too. So grating. I couldn't believe this thing was actually allowed to ship, and people were like, "Oh, this is a great database." No, it's not. It's a base. There's no data that I can trust.
Actually, it wasn't transactional.
Yeah. So yeah, of course it's going to scale. It doesn't have to do anything, But meanwhile, I saw this great video a few weeks ago. This is YouTuber Anton Putra, has some really great videos. And let me see if I can find the one. Here he compares Postgres videos. He compares Postgres to MySQL about a month ago, right? And like for the very large majority of use cases, Postgres just crushes MySQL now in terms of like memory for the number of transactions and the ability to sustain the transactions and just the performance and so on. And he does a benchmarking. He demonstrates all the benchmarks he does. And I'm not saying it's a clean sweep across the board. There are some places where Postgres could improve, surely, but the fact that it is definitely clear that you're better off using Postgres watching this video. I'll link it here. I thought this was very insightful. There you go. That's him. Like it was just a really good. I mean, yeah. So you're saying now it's starting to turn the page. I think for sure it is. So even if you look at this video, he's got let me see. CPU usage for Postgres is a little bit lower after like 10 minutes of sustained load testing. He's got what some people have, because they're no true Scotsman, right? There's always a moving goalpost, but basically he's got like 5 tables that have foreign keys and references, and he does some joins and nothing like. It's not an ERP solution, right? It's not Compare or Salesforce or whatever, but it's still a SQL data structure where Postgres just seems to just decimate the alternative. He's looking at memory usage here. Memory usage for Postgres stays at like 6% all the way through, and then 14% for MySQL. Queries per second seems to scale linearly with both MySQL and Postgres. Select latency P90 is basically the same for Postgres, and actually Postgres has this. No, it's actually like half, depending on where you're looking at. There's little burps, but basically on average, it seems like it's better for Postgres. It's just it's a good result. I mean, this is, when people say, "Oh, Postgres is slow," or I don't know what you're talking about anymore. It just doesn't make any sense. It's clearly very, very good. And if it weren't, I don't know that there are all these large organizations that would be using it now. And I asked Claude, the AI, because I don't want to do, me. I tried doing research once, and that was a bad year. So anyway, I asked the AI, what it thought were organizations and sites that use Postgres. Okay, so it mentioned Apple for various internal systems, Instagram primary database scaled to massive usage, Reddit main data store, Skype main database for user data, Twitch core database. I don't know how old these references are. I don't know if this is like a case study from 10 years ago, or if they just published this last week. I don't know. I have no idea. Spotify for large scale analytics, Discord for core data storage, Mozilla, Firefox Sync, add-ons, crash reports. NASA apparently uses it for various projects. The FAA, U.S. State Department, French National Social Security, European Space Agency, Financial Services, Revolut, the core banking, Robinhood, TransferWise, Japanese banks, Goldman Sachs, Education Research, CERN, MIT, Harvard, Yale, University of California system. I don't know if it's hallucinating all this, by the way. I have no idea, and I don't expect you to tell me. It could be all wrong. I have no idea. It's just the question is, what are some large organizations and sites built with Postgres, right? And I even misspelled Postgres. So OpenStreetMap, of course, using PostGIS. Reddit uses it for multiple Postgres clusters, heavy read-write loads, complex relationship data, vote tracking system. Instagram apparently uses it. I don't know. I mean, it's even if half of these are right, there's no doubt that you can do big things with Postgres at this point, right? Like just an amazing piece of tech.
Huh, okay. I think those, I listened to the people, the companies you mentioned. I think they're probably mostly right. I don't have direct evidence that they're right, but I'm fairly sure that they're pretty close. I mean, I'm aware of NASA. I'm aware of, some of the other financial institutions. But I think the other thing that's happening though right now is that, you talk about MySQL and, Oracle now is the only company developing it. And so, whereas we now have Postgres being developed, and everybody's working. We have some very smart people working for Microsoft, Google, Amazon, EDB, and they're all interested in improving it. Whereas I don't think we have that kind of ecosystem in the MySQL world. So the open source.
MariaDB, is that still a thing? I don't know. Whatever.
It's still a thing, but I don't. Again, we don't have the. I just don't think they have the horsepower, paying attention to it that we do in Postgres, to put it bluntly. Right. I mean, there's some very smart people working on it now.
Yeah, really smart, and it's a ecosystem project as opposed to just this one consolidated thing. I'm a big fan, huge fan. So, can you tell us a little bit about? I don't know. I don't mean to put you on the spot here, but can you give us some of the lore behind it? Stonebreaker and Ingress and all that, like the basics.
So I don't really know that much about what happened there.
Which is saying something, because you started 30 years ago almost, and the fact that this stuff precedes you even.
Well, yeah, that's the interesting thing. So I think there was like Postgres 95 or something, and that's when they actually added the SQL part to Postgres. Before that, it didn't actually have a SQL interface to it. But Stonebreaker wasn't that interested in it at that time. He's sort of come full circle. He's now interested. He's actually, I think, on the EDB board of directors.
Okay.
So yeah, he had sort of gone on to other things at the time. But as far as the kind of the lore, I mean, the interesting thing, I have an anecdote of how I got started because it was interesting.
Sure.
Way back then, of course, there was sort of nobody working on it. It was like maybe 10 people working on this project, right? And so a friend of mine, I'd asked a friend of mine, all right, so I quit my job and I started doing consulting. And so I was doing Java consulting and I was into Postgres and a little bit, but I had a contract and I had a problem. And so I had bought a Microsoft support contract. So I had a problem. So I thought I'd, ask the support contract, how do I solve this problem? He said, well, we'll get back to you in 3 months. I went, oh. I mean, this is back in 1999, right? This is like back in the Stone Age, but right at this point. So I went, but this is not really a feasible solution here. So I started looking at open source, and so I asked a friend of mine. I says, how do you get involved in open source? And he says, just go on the mailing list and start answering every question you can. So of course I went on the JDBC list because that's what I was doing. I was doing Java, so I'm starting to answer all these questions, right? So the first question takes a couple of days to figure out. Second question takes a few hours later, a few hours less, and by the time you've answered like 100 questions, you're able to answer them without actually looking anything up. So, and at the time I didn't actually write the JDBC driver. So another guy wrote the driver, but he decided he didn't want to do this anymore. So Bruce Momjun, who's one of the core members of Postgres, and he's been around at least a few years longer than me, asked me if I wanted to do it. And I said, sure. So that's sort of where it started from. So that's, before it was cool to work on Postgres, I was working on Postgres, but it was, that's sort of how it started for me. And then, at the time I was sort of a part-time thing, and then eventually got a few gigs that I was getting paid for it, and, started working for it.
This is like, this kind of involvement it's organic, right? You start with something, you're scratching your own itch, right? That's what we say about open source people who are getting into something, and those are the best people, because they know what it looks like to not feel the itch anymore. They know what it looks like to have the salve work. And so they're the best judge of what success looks like when you make changes to the code. But so there was already a working JDBC driver at the time.
Oh yeah, there was a working JDBC driver. Yep.
So remember, for folks who aren't quite aware, if you're talking about 1999, remember JDBC didn't exist really as much of a thing before 98-ish, right? So the fact that there was already a good one for Postgres was pretty phenomenal. There wasn't even J2EE at that point. That was still just JDBC as a separate thing that would then be used in J2EE later on. So that's pretty amazing. And it's interesting also that you mentioned the ODBC stuff. So ODBC is, of course, the Windows Object Database Connectivity thing. And in JDBC, there are 4 different kinds of drivers. At least that's what I remember from decades ago, right? You have like Model 1, Model 2, Model 3, Model 4, right? And they're based on how do you implement the driver? Is it like what is it? What is the difference? It's like, do you prefer only Java, or is it a wrapper around some native code, or is it a proxy for something?
Yeah. We're a layer 4 or version 4 or whatever. It's fully implemented in Java. We actually implement the Postgres protocol.
Wow.
There's a couple of projects that also implement the protocol. And so I think, but yeah, so JDBC was actually modeled after ODBC, for better or for worse.
Right.
Sometimes I think it's for worse, but because ODBC was not particularly a great thing. So
no, but I mean, but for Java to get that boost in the very beginning, that's why we had these different affordances in the kinds of models that you could build, these types of drivers. A lot of the earliest drivers for Java were actually wrappers around the native ODBC code, and that mapped fairly straightforwardly to one to the other in terms of concept. So you could get, like you said, in the first year or the first 2 years of JDBC, I remember these drivers coming up. So the fact that there's a Postgres one and it's a pure play, was it always a pure play Java one, or was it ever like
it was pure always? It was always pure.
That's the hardest one to do, and it's worth. I mean, it pays dividends if you can get it right. But well,
we're still trying to get it right. Surprisingly, there's still bugs in it.
Oh, I mean, it's such a complex database, surely. Is the implementation of the driver like Java NIO? This is the thing that blows my mind. Java NIO came out half a decade later, right? Like more than half a decade later. So did you integrate that retroactively, or are you using that at all? Is it still just Java IO input stream, or
just Java IO input stream? So interesting enough, there was somebody that wrote an NIO driver and for Postgres, and for a long time the blocking driver was faster. So I'm not sure where at this point. But it does come with some, there are some issues that we have with the blocking driver, such as, Postgres has this thing of listen and notify, and because of the blocking driver, we don't get the notifies, because we have to actually do a query to get the notifies. So I am looking at trying to, sorry?
The PG notify, the notify.
Yeah, there's a notify listen thing, and it comes asynchronously, so you don't always get it. But
I've actually done videos on that one. That's a pretty cool feature. Speaking of, since I have you, can I ask you about the virtual threads support story? Like,
sure.
Does it?
Yes.
Okay. Next question.
About a year ago, somebody went through all the code and removed all the synchronized code. However, now that we've removed it all, and of course, I'm not sure which version of Java actually supports
21.
So we could actually put the synchronized back in. So
you mean the pinning? Oh, that's 24. That'll be
right.
4 months from now.
Yeah. So, however, It's an interesting problem. Java Enterprise moves very, very, very slowly. We still support Java 1.8 because we have a lot of we just can't get off of it because the enterprise doesn't move as fast as everybody else. There's nobody, they're just using 1.8. So whether or not we support threading or not, it's another somewhat irrelevant to us.
I mean, to the extent that you can just sort of maintain the same code base and have it do the right thing better with no change in Java 24 and later, like in theory, you could have the synchronized blocking code from Java 8, which would perform, expectedly poorly by comparison, and then just automatically benefit from the JVM's magic virtual thread support in Java 24. That's pretty cool. That's actually
actually that's one of the coolest things about Java. The JVM is pretty amazing. I mean, the work that has been done in the JVM, people kind of go, "Oh, it's Java." Well, I've kind of got some, the bad news is the JVM is pretty freaking amazing. So I find it's an interesting ecosystem to work in because of all the work that's been done in the JVM. I mean, you get Kotlin, you get Groovy, you get Graal, you get all these things that you can use.
Oh yeah, I mean, I'm using virtual threads, I'm using GraalVM, I'm using Postgres, like the stack. I'm using Spring, I'm using Java or Kotlin. The stack fundamentally has not changed. I would have been using Spring 20 years ago. I would have been using Postgres 20 years ago. Not GraalVM, but the fact that I can get GraalVM native images and virtual threads from the same exact code, upgraded to use the latest libraries, is
phenomenal.
It blows my mind.
I don't think there's any other ecosystem that has that kind of capability.
No. So the JDBC thing is a full Java driver, and it's at this point. By the way, do you have any anecdotal information on whether it performs as well or scales as well? Performs as in terms of I can get a response back from a single query, and then the other question is, does it scale as well? That is to say, can I handle more requests at the same time? Do you have any idea? Anecdotally on its performance relative to, say, ODBC or Python or whatever?
Oh, I don't have any of that information. I mean, that's a tough thing to answer. I mean, the biggest challenge there is that one is, Postgres is not multi-threaded. It's process-based, so the connection there's a one-to-one relationship between the connection. A lot of the time for the response isn't actually in the driver. The time for the response is in the time it takes to get to the server, the time it takes to get back, the time it takes for the server to actually do things. How much time it takes in the actual driver is probably an insignificant amount of time. We have seen some speed ups in sort of being able to run things in binary mode. In the Postgres protocol, you can ask for information in text mode or in binary mode. So we've actually seen a huge speed up. Recently you mentioned AI and stuff. There's a pretty popular extension called PG Vector, and when they first implemented that, everything was coming back in text. And one of my colleagues mentioned that this was a little slow, and I said, "Oh, well, you can do this in binary." So okay, cool. That speeded up almost doubled the speed right away. So. That was all built into the driver. That was it was very easy to do that in the driver.
I do presentations where I talk to people about the PG Postgres plus the vector plugin, right? PG Vector, all the time. I mean, I just did a presentation at midnight California time this morning, for some folks in the UK, for example, and I quite like that. I mean, the fact that I can just use good old friendly Postgres and take it to these new frontiers is one of the reasons why I love Postgres, because I don't feel quite so locked. Like you're not logged in if you have access to every plugin out there, right? Like there's no such thing as lock-in here. And to the extent that I can actually get some of the same benefits just using my old friend Postgres as I might by switching to a completely different data store, pick, have your pick, right? I mean, there's a million of them. It's one of the reasons why I love it. It's just incredible ecosystem. My question then is, what is the interaction with the driver when a plugin adds new things to the server? Like, how does the driver know what to do with a vector? coming back from the server, for example? What does that look like? Is there any coordination there? What about PostGIS? When PostGIS adds geospatial constructs to the server, does that, I don't even understand how that, I mean, do you have to have a conversation with it? Because it's not like an official part of Postgres, right? It's a third-party thing. How does the Java code learn about it?
So let me answer the first question about PG vectors. So in the PG vector, I think he actually created a PG vector type. So he was able to, there are custom types in Postgres. So you get the type coming back. The type information is in the protocol. Then you know how to handle it. Then you can read it into a custom object in the Java world. The driver really doesn't get involved in that. Now, in the case of PostGIS, the guys from PostGIS wrote a whole lot of code to actually handle all the different kind of custom types in there. So, but it's all done with custom types. So it's referred to in the SQL world as domains, but they're user-defined types. But that's all done sort of in the Postgres protocol. But you're right, though, that the ecosystem and the flexibility of Postgres is probably one of the other big reasons. We didn't mention that, and why is Postgres so much better? But like you said, we have. Forget about JDBC. If there's a computer language, there is a driver for it in Postgres. If there's a reason to have an extension, there's an extension for Postgres. So you can we recently added JSON, which basically makes it a NoSQL database.
Oh wait, you mean you're not talking about a PLP like a PL JSON? You're talking about like as a data type.
Yeah, as a data type.
Okay, right. That, yeah, totally.
You can store unstructured data and have it transactional.
Oh, I know you can also do you can select attributes from the JSON structure like they're columns in a table.
Yes.
Is that recent? I thought that was been there for a while.
No, it's been there for a while. But I mean, the fact that we could just add JSON to it, and it wasn't that difficult to do, right? It was,
right.
The harder thing for us was litigating how we were going to do it, which is one of the things we're very good at Postgres.
Right. Well, I mean, got to get it right. Millions of people will be affected if you get it wrong. I understand a little deliberation. So the Postgres thing, I guess what I'm trying to say, you've got a comment about your beard. Apparently your white beard is awesome. So there's that. Very nice thing. So did the Postgres, the PostGIS stuff require any coordination in the driver? I mean,
I have no idea what they do. I used to work with Paul Ramsey, who's one of the PostGIS guys, and Martin, and they wrote all that code, and I have literally no idea what it does.
Right.
They didn't talk to me about what had to be done, and I didn't have to help them with anything. It worked. It all works without any kind of coordination between the two of us, which is pretty amazing, right? Like they were able.
But how do I get a strongly typed Java type pointing to a thing that doesn't exist in Postgres?
Because they actually created the types
in the Java driver.
They added, so when it's not in the Java driver, when they get you can get an object back, right? So you can do get object from the result set, and when they get the object, they get their type back.
Okay.
Yeah, it just builds a type.
I guess I need to try. I'm unclear, obviously, about how this, because I'm so used to using the PostGIS stuff from the Spring Data layer, which
somebody's done the work for you already. But yeah, we actually do have a few types, right? We have PG box and so some other little types, but we don't really do too much with too many other types.
Right. Okay. So that's what I guess
you can register a type with the OID. So if you know the OID is the ID of there's a metadata table and catalog table in Postgres, which is called PG type. You can add it. So when you add a type, it has an OID, and when the result set comes back, you get an OID, and you can say, okay, this OID maps to this GIS object, and automatically know how to read it.
So it's literally just a table.
So so that's the cool. That's the cool thing. Postgres is actually object oriented. If you look at the catalog, it is all like an object oriented catalog. Everything has an ID. Everything references other things in the catalog, and you can build an object model for the catalog.
I never realized it was that easy to like connect. I mean, I you know, if there's only something that was missing, I would be incentivized to try and figure out how to write a plugin. But there are no gaps that I could foresee, and so therefore there's no reason for me to learn. Yeah, that's amazing. Okay, that's interesting. I didn't realize it was that direct a connection. Do other drivers benefit from that same mapping? I mean, I'm sure they
Absolutely.
must. Right?
Oh, absolutely. They can do exactly the same thing. There's nothing magic about what we do. We we'll get back. So basically, when you make a request, you get the fields first, and the fields have an ID in them or an OID, which tell you what the field is. And if the field is a square or a rectangle or whatever, you get the OID back for it, and then okay, this is how I read it. Even with arrays are the same sort of thing. There's a complicated mechanism for knowing how to read an array out of the protocol.
Right. So, oh man, that's really good. You mentioned that earlier that it's a process per request.
It's a process per connection.
Yeah. So on the server side, there's a whole process. It's not a thread. It's actually a process. Like
it's not a thread. It's a process.
You're spawning a new thing. What are the? I guess that makes concurrent. I mean, is that why you have MVCC? Like, is that why you have to be so careful about having?
That's not really why you have MVCC.
Because you have no semaphores in the language anymore, right? It's now process based. So how else would you create exclusionary views besides that?
Well, that is how we create exclusionary views, but it's you could do that with threading just as easily. MVCC is just a technique to have exclusionary views. But there is actually some people in the community that want to try to do multi-threading. We'll see how that goes.
I mean, it couldn't be famous last words, of course, but it could be good, right? Like that sounds pretty interesting. Like the overhead of having a process.
Apparently Oracle tried it, and the results weren't exactly what they thought they were going to get. So,
Well, okay. Now I'm nervous. Wait, so they're going to try it in Postgres proper, or are they going to like create a form?
Yeah. No, there's a group of people that think that multi-threading is the way to go. So they're smart. They're not. These are guys that I hold in high esteem. So I'm interested to see how things go. We'll see how it goes.
Yeah, that'd be really cool. Because again, this is one of those things where if you're using Postgres, people like that can do things like that. You upgrade to Postgres, whatever, 30 or whatever in some years, and suddenly you've got hopefully even better scalability just for free, or you've done nothing. You've just, these are the kinds of epic engineering efforts that take decades or years. I mean, even virtual threads in the JVM took more than a decade to really come to fruition.
I do think that databases are a little different, and as far as whether or not multi-threading is going to work, because ultimately it comes down to resolving conflicts on the disk. So we can't. I recently had a conversation with somebody who wrote an application and thought they could just multi-thread this application and sort of run it on a database, and it would just sort of magically work. And I said, well, JDBC isn't multi-threaded. And he says, oh yeah, I found that out. So it was like I've been in the database world for so long that I just sort of take that for granted that ultimately we have to talk to a disk. And,
right.
We can't just sort of ask for data all over the place at the same time and expect to get a concurrent a view of the data that's correct.
Right.
Out of every thread.
Right. No, somebody's going to get the old stale view.
Right.
Or block, I guess, which is what we want to avoid with MVCC.
But the idea that you could actually have all these threads just hitting the database and sort of working magically was something that he didn't realize that this was going to happen. No,
So if we moved to a multi-threaded approach, you're saying there'd still be synchronization ultimately at the very last line of defense, because only one person can truly make a change there at the same time, right?
Yeah, right.
And so you might, but it would in the meantime have the effect of lowering the redundant process space.
Yeah. It does make some things easier. Like currently we have to have shared buffers to communicate between processes. We have to, as you say, we have to spawn up a process to get started. That's an expensive. That's expensive. That's why things like we have connection pools that exist. PG Bouncer is one of the famous ones. That's why those actually exist, because it is expensive to spin up a process. So if you were just running multi-threaded, it would be there's no process to start. Just start a thread and away you go.
Yeah. That's another thing. I mean, the tool, the database has, over the decades, it has become more and more critical to large scale systems and services, about which we just spoke, some minutes ago. What are some of the you mentioned PG Bouncer? That's a connection pool on the server side. There are obviously on the Java side and the client. There's obviously different connection pools as well. Oh, by the way, what do you know about connection pools on the Java side? Which one should people be using?
Oh God, I'm not answering that question.
Okay, just wondering.
We tend to use Hikari, but I don't have an opinion really. I mean,
okay, that's what we're using. I just wanted to know if we were basically on the right track. But on the server side, you've got all these things that are not exactly SQL standards, but that exist in all the databases in different incarnations, and that serve to support scale, right? And to do so as transparently as possible. So in Postgres, I know about a few of these things. Obviously, you mentioned PG Bouncer. There's also sharding. You can do table sharding, for example, to
partitioning. You mean
partitioning? Yeah, thank you. What else? You've got clustering, I guess. What's the story for clustering these days? What do people use there for read versus write nodes? Is that
so the popular open source cluster, if you will, is Patroni. There's a few people out there. So that is basically a one writer and one primary, multiple readers.
Yeah.
There are a couple of Enterprise DB has a proprietary solution for doing primary. But as far as clusters go, supported by the Postgres community, we don't have a solution. We're sort of singly focused on providing a single instance, which I think has to change. Personally, this is my opinion, not the Postgres opinion, but I think I personally believe, or personally see, or don't see anybody ever running a single version of single instance of Postgres in any kind of scale. So I think it would be a good thing if the Postgres community could figure out how to at least make clustering easier for people, add some features in to make it easier.
Yeah, I mean, that'd be really good. And the fact that it works is pretty amazing. But I think if you also had some better support built in, as you say, I wonder what effect that would have, if any, on there are different databases that purport to be Postgres compatible or wire protocol compatible or whatever, but there are they're not exactly Postgres, are they? Right? They're Postgres with some modifications, or maybe they've ripped apart the engine a little bit or whatever. So you've got the CockroachDB, the Yugabytes, these other sort of Postgres alikes whose raison d'etre is to bring the joy of the Postgres modeling and grammar and feature set to a horizontally scalable sort of workload, right? And I don't know. It's not like there's not a solution for some of this stuff now, but it would be nice, as you say, to have that sort of built in. I wonder if that would be. I wonder what effect that would have, if anything, on these other implementations.
That's a good question. I think one of the challenges we have or I think one of the challenges the community has as a community is trying to figure that out. As you sort of mentioned, you have to get it right, and we're kind of letting, for better or for worse, I think the other companies or the other organizations or open source projects are trying to figure out what is right, and I don't think anybody's actually got it perfect yet. So I think they're all interesting experiments. The one cool thing that they get, though, and one of the great advantages of Postgres, is that it is completely open source.
Right.
And, the Postgres license allows you to create a company for it, allows you to make money off it. But when you do this, you get this huge ecosystem. You get all the extensions, you get all the drivers, you get the protocols open source. So you don't have to write. I've heard, of other large companies with, multi-million-dollar client implementations, right? Like they have, hundreds of people working on the clients. They don't, they're getting all that basically for free. So, they get the advantage of being able to just, add their secret sauce to, whether it's, like you mentioned, CouchDB or not Couch, but Cockroach and Yugabyte and a few others, Citus did it. They got, Citus is still around a little bit.
Oh yeah, so Citus, so that was now part of Azure, right? That's
Microsoft.
And then Petroni is the open source, like that. These are both horizontal scaling solutions, right?
Petroni is more of just a way to manage, like a warm standby or hot standby.
Right.
It scales for read
many
multiple readers in one writer.
Right. Yeah, which I think is actually fairly common. I would imagine most sites are read only or read most, read mostly. So that seems like a very useful thing to start trying. Because the alternative is that you get these denormalized solutions where you're doing writes to a Postgres, but then you have a asynchronous sort of write behind to a Redis for the read, for the constant time read. And so having the ability to make read scale and available, yeah, I mean, it seems reasonable. Seems like it would be a good first cut at scaling out a system using Postgres. Obviously, your workloads will determine that, whether that's true or not. But like, for example, Reddit, I don't know what their architecture is like, but one imagines that most people are reading Reddit as opposed to writing to it,
Yeah, for sure. Although I do think there's a huge market for, what you're talking about is, but the other one is sort of a change data capture. And I think there's a huge market for that. I think there's a huge, that pattern is pretty amazing, especially for financial institutions where they collect the data at the edge and then they push it out to wherever, and they can have, multiple paths of where that's going to. The Debezium folks.
Debezium.
Gunnar. And
love him. So good.
So, they're interesting because they actually pushed my implementation quite a bit. So we've got a lot of, we've had lots of, collaboration there to make it all work.
Yeah.
So that's been pretty cool.
Doesn't surprise me. That's a really cool, that's based on the write-ahead log that you guys put out, right?
So that's based on logical decoding. So it is a write-ahead log. So the write-ahead log has, it has a logical stream, and it also has a physical stream or a binary stream. The binary stream is used for like binary replication. But if you want to get something that's readable by sort of a program that you can, the way it works is you can actually add your own decoders to it and encoders. So you just get the data and encode it and decode it any way you want. Again, it's flexible, just like everything else in Postgres, right?
So for people who are I wonder what of the last 2 minutes of conversation makes sense to a lot of people. Change data capture, CDC, is the idea that you emit as an event the delta in state transformations on the database. And so the idea is that you can say this record changed from this to this, and you publish that as an event or something so that somebody else can consume that and then modify their own view of the data accordingly. Debezium is an open source Java project that takes the log called the write-ahead log, the WAL, from Postgres, and it sends it off via Kafka. So now consumers can listen for those changes via Kafka. Am I missing anything so far?
Actually, Debezium will let you do it any way you want. You don't have to go to Kafka. You can go to anywhere you want.
Right.
So the cool thing is previously the way you used to have to do this is people would create log tables, and triggers. So they would have a notion of something changed in the database. Somebody updated the balance in their bank account, and then they would have a trigger would fire, and then the trigger would put this data in a log table, and then somebody else would read the log table and they'd delete the record.
Right.
That caused a lot of churn, a lot of extra overhead on the database. And if you manage to miss whatever, whereas CDC, with logical decoding and CDC, if the database crashes, you don't lose the data. It'll still be there. When you bring
Right.
the database back up, it's still there.
As long as the first thing was committed, then you don't. Then it's effectively going to get reconciled later on, right?
Yep.
Yeah.
So
that's super good. Super good. Actually, that brings me to another question, which is, what is the role of the languages? You mentioned PLR earlier, and one of the things. I mean, I've used the Java. There was Java. I'm not sure if there's any more, but there was a PL Java.
still there. Still
Yeah.
exists. PL Java still exists.
I haven't used it in decades, but I know it exists. And there's PL Python. I remember that one. There's Perl from decades ago. I'm sure there's
Still
two people
exists.
using that. Yeah. And Ruby and just everything. I mean, anything. It's Tickle. I'm sure there's just every language you can imagine. You can run as a sort of a stored procedure.
It is a stored procedure, so you can write a stored procedure in any language you want. So there is, PL, the sort of the built-in one is PL/PGSQL. That was written by Jan Week. Jan Week also wrote PL Tickle, but as you said, if there is a language that exists in a computer language, there is probably a language in the Postgres, for a procedural language in Postgres, and it just allows you to write a procedure in any language you actually happen to want to do it.
And so the stored procedure. So you mentioned the triggers earlier. You can have a trigger function that then responds to an event in the database, and it could just be a simple PL/PSQL trigger function that does DDL or some sort of thing. But also, you can run Java code. You can run Python code in response to a database write, and that runs in a separate process on the same server as the Postgres. I never really understood that part. Or is it in the same process? Or
it's actually in process, which makes it a bit of a challenge.
Whoa. Oh, wow. So you want to make sure you don't spend too much time in those triggers doing, you don't just sit there and read the funny papers. You got to get off that, execute as quick as possible, right?
Yeah. So I actually did write a PLG JVM, which was more like a remote procedural call. So it didn't actually run in process. And that never got anywhere other than, a couple little things.
Oh, that's a bummer. Is that more like fire and forget? It just sends the request to the JVM and lets it handle it, and then use the server? Okay, that's really nice. Yeah, see, that's what you would want, is to not gum up the works in the server process itself,
Yeah.
But I don't. So you mentioned the R one. How does that, do you have the ability to do R functions?
Whatever you can write in R, you can write in this function. Yes.
So how's that work? Like when these plugins are installed, do they install the R runtime and the Java runtime? And
they don't install the R runtime. The R runtime has to be there. We just link into it. It's just so there's an API and we just link into it. But you have to install it ahead of time.
Is it actually doing Java minus jar, or is it doing Java? Java, the source code that you provide in the function in Java.
No, so the PL Java uses Ginny, right? So it actually just calls through JNI. So it would have to fire up the JVM if it wasn't running. But
okay, but that's what I'm trying to figure out. Does it keep the JVM warm?
In the process, it would, yeah. And then it would run a jar. Yeah, it would load a jar and then run the function in the jar. So, which is it really, it was really, PL Java existed because of Oracle. Oracle wrote their own JVM in the Oracle database, which they had the advantage there for sure. So in the Postgres world, it didn't really make sense because there was, the overhead of running a JVM in the process was huge.
Yeah. No, I get it. And actually, it sounds like you've got the best solution, because most of the latency in Java is in the startup. But as long as you've got the JVM running, then it's going to be plenty fast,
But also, one of the things in my spare time, which I can't find any of, I'd like to do it in Graal, in native.
Yes. So apparently that's what they're doing in Oracle. That is the genesis of GraalVM. I talked to Thomas Wertinger on this very program about a year ago. You weren't available at the time. I believe we talked. And Thomas said that when he created GraalVM, one of the things that he had to do was to, any large company, you always got to find a way to tie yourself to the big product, right? And so he had this, daring idea to build this ahead of time optimizing compiler. And of course, where's the connection there to to the moneymaker, Oracle database, and later Oracle Cloud. They realized they could use this to actually embed Java and have it perform really efficiently in the database, right? So he created that that was the first like cut of the native image support there. And then it got generalized into a thing that could support everybody, as opposed to just the native integration in the database itself. So yeah, I think it would be really good for that use case. We know, there's a existence proof in the current implementation in Oracle.
Yeah. If I could only find a few more round to it.
Sorry. Just because it's easier doesn't mean it's possible, because without time, right?
Exactly.
So cool. I mean, there's this Postgres thing. I didn't know there's an attempt. I didn't realize it was a server process. So when you say that, I cannot, I'm sitting here giddy because I don't really have, look, I've used some of these tools to like scale out, and I've certainly been in projects where we were using them, but I've never really had to deploy them myself, to get better availability or consistency, right? I mean, just all these tools to scale out and to make my code go faster. I didn't realize that was all being done despite the fact that it was all in process. It was a process-based thing.
Despite
what?
Well, it's interesting. You use the word despite the fact that it's in process. It does
right.
It is pretty efficient. So it's
Yeah, like imagine if we if these people are right and there is something to that, that would be just, I cannot wait. I mean, that's like a Christmas. You wake up and Sunday Postgres is even better somehow.
Yeah.
What about, okay, so the code base for Postgres is C and C++?
The code base is actually just pretty much C.
Okay. And does that make life fun, or?
Oh yeah. Oh yeah. So it was originally written in Lisp. So there's like
really?
Yeah, really.
When it was called Ingress?
I don't know what it was called when Stonebreaker actually did it as his PhD thesis, but so there's a whole bunch of so at one time, I don't know how much, it's been a while since I've been in the back end code, but there's a whole bunch of lists, and traversing all these lists, and it turns out that that's not very efficient with today's processors. So I think they're mostly going away, but there was a whole lot of code that was but the basic, when you're in the back end code, you could be looking at one piece of code that was written 30 years ago, and you could be looking at another piece of code that was written yesterday. And the rule is you have to match the style wherever you are.
Not to carry it forward?
No, you can't just go rewrite the whole thing just because you like the style better.
Well, I mean, so normally if I work on a project, it's, whatever you touch, you update, right? So if I touch a piece of code that's one code page and it has these functions, I'll just modernize it, not being sure to not break everything else, of course, but.
Yeah, no, you kind of got to match the style, wherever it is.
Oh dear. So you got to be, you're fluent then, not just in C, but in 3 decades worth of C.
Oh yeah, there are style guides of how you got to write it and stuff like that.
Right.
And there's a ton of macros. Which end up making your code look like it does something, but does something completely different. It's an interesting challenge.
So I don't mean to be that guy, but has anybody, has nobody suggested gradual rustification of the code?
Certainly has been brought up. I think there's some discussion about doing it, but it's, everybody's kind of, I've heard this story before, right? Let's just rewrite everything in Rust. And,
or parts of it, like Linus is doing.
You got to find time.
Yeah, it's fair.
There's other problems to solve besides writing it in Rust. And Postgres, the one cool thing about having it in process is if the process goes away, we don't have a memory leak.
It's true. That's actually true. Yeah, it doesn't matter how poorly set it up it is. Yeah.
Well, actually, we actually do have our own memory. We don't use malloc. We use something called palloc, which is Postgres alloc. And at the end of it, once the process goes away, or once the request goes away, actually, the memory just goes back. So there isn't really the memory leak problem that people would like to think there is in C. That we don't have that kind of problem. We do it. It's not to say we don't have null pointer errors, but it's not as dire as thing. And there's a considerable amount of time that goes into any patch to make sure that there's a lot of people looking at patches to make sure that there's no bugs or obvious bugs and things like that.
Well, of course.
So I don't personally think there's like this huge bang for your buck to rewrite everything in Rust.
Not well. Nobody's talking about rewriting everything. I'm just wondering. I don't know. I have no idea. Literally no idea. But I've noticed, like even the Mr. Curmudgeon himself, Linus Torvalds, seems cautiously and angrily indulgent of some of these attempts to, off in the fringes and the hinterlands of the code base, conceptually rewrite some of those things. And of course, it's not inspired. It's not making any friends, And I've noticed that in the traffic there on the mailing list, there's this. I mean, didn't they just have somebody who resigned because of this? And the guy the person that was working on that part of the effort was just so tired and frustrated from the constant pushback from the other C maintainers that he just resigned in frustration, and it's not going well. So yeah, I wouldn't wish that upon the Postgres project. But I do wonder, the United States government just put out a paper talking about how they want memory safe languages. Of course, that was today's government. We'll see what happens. Anyway, they put out a paper encouraging people to use memory safe languages, and I don't know that Rust would make Postgres any faster, but it might make it more memory safe. But if you've got Palloc, then maybe it's fine. Maybe we don't care until that multi-threaded thing starts to become a real thing.
So because the government says we want you to do it doesn't mean you're going to do it. I mean,
no, it's encouraged, not required.
They're more reliant on Postgres than we are on them. So, I mean, I get the desire to do that, and I do think that it'll be harder and harder to find people to write in C versus Rust. So ultimately, it will happen. It's just probably not. Well, I'm working on it.
Oh, I don't think that. I think it'll be decades before the number of Rust programmers ever exceeds the number of C programmers. I mean, I'm a few years younger than you, I think, and even I know C, right? Like, C is. I don't know Rust, but I definitely know C. I can write C. I don't want to. Just to be clear, don't send me pull requests in C, please. But my point is, I think a lot of people know C. You kind of have to.
I think my point here, though, is that if you're just coming out of school and you got a choice between which language you're going to focus on, not necessarily know everything, you probably wouldn't choose C. You'd probably choose something like Rust, because the opportunities, as you just mentioned, the government's saying we want more memory safe languages. You're probably going to choose Rust. So and finding people that are going to work on a Postgres community or a Postgres code. It'll be harder and harder, I think. We do have, obviously people work in C. So
yeah, I was gonna say there's more jobs in C. There's, and it's not even close. It's like 10 orders of magnitude. Like it's yeah. I don't know. I think you need to learn both. Really, is I guess what I'm trying to say. There's no world where C doesn't. I mean, and again, I'm the Java guy. Don't get me wrong, but even I understand this. C is going to be here for forever. Yeah. I don't know. Whatever. Yeah. Screw Rust. Who cares? I'm just. I don't know. I mean, maybe you rewrite it in Java and just use GraalVM. Yes. Let's go.
I'm sure that happen anytime soon.
Yeah. Okay. Right after the Rust port gets done. Yeah. No. That's. I mean, it's just. I didn't know. I mean, all I'm saying is that the fact that it's so freaking good already, and it's got this process model. I didn't even realize that. I mean, it's not low hanging fruit. I'm not saying that. I'm just saying. It just seems like there's some opportunities there that I didn't even realize. The fact that it's this good despite all that is wow. I mean, what an amazing piece of engineering, and it was in Lisp at first. I mean, that's
that was quite a while ago. That was probably in the very early 90s.
But still though, what a nice piece of software. So why did you get into Postgres? So you had a Microsoft contract, you said. Why
I had a contract to do some work in Java at the time. There wasn't really. I was doing it in Java, and I bought a contract. I don't know. I was doing it on Windows, so you had Java, and so that's kind of why I got into the Microsoft contract.
Okay.
There wasn't. I don't think there was any way. Sun would have owned Java at that time, so
Yeah.
there wasn't really.
And they owned it. It wasn't open source. Yeah.
Yeah, it wasn't really a way to get a Sun contract for support. So Microsoft contract. It was a Microsoft developer. It was you could the MSDN thing, the Microsoft Developer Network, and you could buy a contract
and get the CD.
Yeah, it came with a bunch of CDs, right?
Yeah. Visual Studio C++ 6 or 5 or whatever it was.
Yeah.
All the Visual J++. Let's not do that.
Yeah, J++. Exactly.
So you got into Postgres at the time. Oracle was already a known commodity. Sybase was already a known commodity. Postgres, how entrenched was it? Because this is before, you said they only added SQL in the mid '90s. So if you went to an organization and said we're going to build everything on Postgres, what was the average response at the time? I guess is what I'm trying to figure out, right?
So probably when I started, I wasn't really, I was using Postgres as it wasn't an enterprise thing. I think I got my first bigger contract to do anything in Postgres probably in 2005, 2008 maybe. And it was a large grocery company in Canada that wanted to switch off of HPUX, and they were using Informix, and they had a 4GL language, and so they wanted to go all open source, and so there was people that were doing it at that point, but they were we're talking about people that had some vision as to how open source was going to play out. There wasn't a lot of people there at that time wanting to do that, for sure.
Well, it seems like a smart bet at the time. I mean, you don't hear about Informix very often anymore, so
no, I don't think that's survived that particular CIO, but for the time when I was getting paid, he was behind it. So
golf games. What another database that I've always liked, and I kind of wondered why. This one I don't actually have any understanding as to why it didn't take off. You ever use a Firebird?
I'm aware of Firebird, but I never used it in any real capacity.
You and me and most of the world has never used it. It was one of those nice databases that it was featureful, and I can't point to any reason why it never really took off. I can point to reasons why Postgres at first, no Windows port and the like, but now, I don't know. It just seems like I'm just remembering that there was actually another database that would have been really nice compared to MySQL 20 years ago as well, 25 years ago, and yet people still chose MySQL. There's two of them.
I think the bigger reason why people chose MySQL was because you could click on the Debian or the Red Hat package and say, give me the LAMP stack, and all of a sudden, you had a stack. Whereas there was no Firebird stack. There was, there really wasn't even a Postgres stack. So it was like, you just downloaded the packages and away you went. So, and as at the time, MySQL was certainly easier to use than Postgres. So.
Yeah, I guess. I don't know. You have to set up back then you had to set up roles, and you had to set up do all that stuff manually, whereas MySQL was just wide open, festering wound in the middle of your security network.
Well, that's the way they liked it.
Yeah. Oh yeah, look at that. Firebird, Axion, Interbase, and Derby. Is that
Derby? Remember that?
That's a SQL database from Oracle, right? Or
no,
IBM. IBM had that one, right? Okay. So I don't mean to linger in the past. It just occurred to me there's this other database out there. What is coming in Postgres? It's it's obviously, I think it's fair to say it's the standard these days. I can't imagine using. I think Postgres brought us back from the NoSQL era. There was this sort of, I think, discontent 10, 15 years ago around the offerings coming from the SQL databases. And the way I kind of see it is that we were looking for options in terms of scalability and for specialized data types. And now, Postgres is good enough for most use cases, and it has these specialized data types. Like you just said, we have JSON, and we have XML, we have PostGIS, we have full text search, we have all the stuff that you might have otherwise had to go to different vector stores, all these different things that are the foundations, the basis, the raison d'etre for all these different data stores out there. So now Postgres is, I think, very much the standard. What's next? What's up look like? Well, upward and outward. What does it look like?
I wish I knew the answer to this question. I think it's like anything else. The thing that will happen next, we don't really actually know we can't predict the future of the next big thing. But I think in general, I think what you're going to see is that we're going to get a lot more performance out of Postgres. We have a lot of people working on that kind of stuff. There is performance to be had. Just we're working on it. There's some of the people like Peter Gagan working on indexes, and we mentioned the PG vector stuff that kind of came out of nowhere. I honestly couldn't tell you what the next big thing for Postgres. I would like to see clustering of some kind. I do know that they're working on incremental backup, which is surprisingly you think we'd already have.
Well,
but we don't.
Okay.
Well, one of the big challenges with Postgres now is the data is getting big. There's sort of a couple of different ways to back up your database. One is PG dump, which basically dump the data in a text format. But now databases are so big that you can't actually dump it in one day. So if you can't get it all out in one day, then you can't get a daily backup. So we're starting to look at incremental backup, which was just added. It's not really ready for prime time, but it's come along. There's a couple of projects that support backup now.
Wait, so it's like a Git file? I mean, like, do you have a?
No, it's not a Git file. It's basically manipulating the wall logs. So each incremental chunks of the wall log.
Okay, so because when the last offset was when you took a backup and you just take all the events.
Yeah.
After. Okay. I mean, it sounds easy, but of course, I'm sure it was excruciating.
Oh, there's a bunch of stuff you have to worry about there, but
sure, yeah.
But I'm sort of my biggest challenge with the Postgres is getting the protocol changed.
Oh, what? Why?
Why do I want it changed? For performance and for more information. Some of the stuff that wasn't in there that we would like in the Java world or any other client world for that matter. It's one of the things I mentioned earlier is you can get data back in binary or text.
Right.
Or you have to, I'll avoid giving you all the details, but you have to do an extra round trip to get the types that you have to ask for in binary. I would like to just say at the beginning of the session, give me all these types in binary.
I see.
So, but changing the protocol is one of those things that, as you mentioned, you got to get it right. And
you got to get everybody else involved as well, right? Is this?
That's the other problem. Like, it has to be such a way that everybody can use the old protocol and then also leverage the new protocol.
Is there like a versioning scheme for the protocol itself? Like, is it possible to do things like this?
There is a versioning scheme, but we're working on a versioning scheme that's a little more extensible, and we're still, we've identified a number of needs to changing the protocol, but nobody's actually come up with a viable solution to actually, concrete solution to changing the protocol. So there has been another protocol. Like, we're on version 3 of the protocol. Version 2 protocol, sort of just, it had been there forever and kind of dropped off in the last 5 years. So
are there clients that could still use that if they wanted to?
No, the V2 protocol is gone.
Okay, good riddance.
But it has it has a surprisingly long lifetime.
The new generation of protocols, that's interesting. I didn't even think about that. Like, I mean, it is a classic client server problem. You have evolving consumers and producers. Obviously, that's going to change.
So,
and imagine having a protocol as multifaceted as SQL, and not to mention all these.
The protocol itself is actually pretty simple. It's only not very complicated.
Okay.
But it's just changing it is complicated, just because we have to future-proof it. So
right. Yeah. Well, this is I think you should do a talk whenever this stuff lands. I'm sure the software industry would love to have a talk about this, because the insights on changing the engine on a plane while the plane is still flying.
Yeah, exactly. Right. It's difficult.
Oh, okay. So then what's the big thing in the Java client? Because as you said, you still have to, care for the Java 8 users. What's the
As
next
I
big
mentioned,
thing?
so as I mentioned, I would actually like to make the protocol more, or the JDBC driver asynchronous. It's currently synchronous. I'd like to make it asynchronous. We have support for user-defined types. We've got a pull request for doing that. That was done as a Google Summer of Code project. The guy did most of it. It's hasn't got finished yet. Anybody that wants to help out reviewing pull requests, I'm more than happy to have you come on board. That's one of the challenges is finding people to actually review pull requests.
Yeah. Well, can you imagine getting a chance to work with you? That would be a real privilege. I'm sure doing that with this is the beauty of working in open source, people, is if you get a chance to work with somebody like Dave, you're going to learn something, So where do people go to, first of all, where do they go to start kicking the tires, looking at the source code? What's the canonical place to find the code on which you work, for example? Let's see.
pgjdbc.git.
I was going to say, you don't have a...
I don't have it. I just type it in. It comes up. It's one of my, the AI just knows where everything is in my thing, right? So
it's a PGJDBC.
Yeah. Does that come up? Does that come up with chat with everyone in the studio, or does that come up as? No, there you go.
Yeah, there you go. Excuse me, friends. Gotta blow my nose again. Okay, so this is the PGJDBC code. People can find you there, and if they want to learn more about the drivers, I mean, I'm sure releases are released there as well, right?
Yeah, everything is released there. So it basically comes from there. Gets pushed to Maven. Interestingly, I had no idea. I still have no idea how this is possible, but it gets 20 million downloads a month.
Oh, I'm sure a million of those are just me. I mean, I'm a huge fan.
It blew me away when I saw that number. I had no idea that it was that large.
I'm sure it's actually markedly bigger because there's a lot of corporations that have artifact repositories that are doing caching. I'm sure it's 100 million or a billion, maybe even. It's just, it's such an amazingly good project. And like you say, even the hyperscalers are converging on this. It's one of the true few things in open source where we all just said, yeah, that'll do. We'll have that one. Like we have Linux and Postgres in which we trust.
So that sort of reminds me that one of the things that some of the other people I mentioned, Bruce Momja and a few other people, but one of the bigger things that they've said, or I sort of live by, is one of the things I have to worry about is just not breaking the thing. So there's a temptation, like let's add this, let's add this, let's add this, and I go, well, it's not, let's just step back a bit,
Right?
Is this really a feature that everybody's going to use, and is it really worth doing? Because breaking it would break a lot of people's code.
Unfortunately,
I have done that before.
Oh no! How bad was that? Like, do you get pagers like minutes later, or what?
I don't get pagers, but I get people tell me, oh, this is broken, so it's either have to revert the good thing about GitHub, you revert the pull request and you issue it, push out another release, and go back and think about what you just did, and maybe not do it, but yeah, it does break a lot of code in a hurry.
Well, because it's such a stable project. I wonder how many people just automatically upgrade to the latest and greatest anyway, without hesitation, because it does work so darn well over so much time,
Well, with dependent bot, we see a lot of people doing it now, right? They just, or if you have a security release, all of a sudden it's like boom, there's tons of people.
We have a comment here. Hot take. You cannot get worse than that one commons logging release which broke everything. I don't know to which release that refers, but okay. Anyway, there have definitely been things that break things, that's for sure. So that's good. That's PGJDBC. Obviously, PostgreSQL.org is the database. I don't think I mean, just type that into a browser. You'll get where you're gonna get going. What about yourself, there, sir? Are you on the internet? Do you want to be found? And if so, where can people?
I'm
find
not
you?
really on the internet. I do. I don't have a web page. I don't really have too much in the way of a blog. I'm on Twitter as Dave Cramer. I think I'm on Blue Sky. I think I heard that everybody was moving to Blue Sky, so
I'm there.
I started it up again.
It's nice. We have cookies. Come on in. Water's warm.
So Dave, actually, it's just at Dave Cramer.
Blue Sky. It's no at dots, Dave Cramer.
No dots, no nothing.
So you do your own domain thing?
No, I have these. Just type it in there for you.
Dave Cramer. Oh, but you're davecramer.bsky.
Yeah.
Okay, so you can do your own domain too. You can actually say like davecramer.com. But
okay. Really? I think there's a couple other Dave Cramers around, so I probably lost that opportunity.
Well, I mean, no, it's tied to your domain. If you put, do you have your own domain? If so, you can put DNS record in there, and then Blue Sky will give you authoritative rights to, like, for example, my handle on Blue Sky is starbucksman.joshlong.com because
really?
I'm the authoritative DNS holder for joshlong.com.
I actually do have postgres.rocks, so maybe I'll put.
Well, there you go. You can be that on Blue Sky.
Cool.
There you go. Dave, this has been so good. I'm a huge fan of everything you're doing. Obviously, I speak for millions of people when I say that we're all big fans. It's one of the most instrumental projects on the freaking planet, and it is changing day by day, even to the point where a dullard like myself can see it and appreciate it. There's market changes all the time that just make it better, and I couldn't be more grateful. Thank you for taking the time today on a Friday. It's been a real pleasure to talk to you. Thank you so much.
Thank you for having me on here, Josh. It has been a pleasure. I've enjoyed every minute of it, and I'm a big fan of your work as well. So,
you're thinking of somebody else, but I appreciate that. Okay, everybody, have a nice weekend, and be good to each other. Bye.
Bye.